Thank you. Thank you all for being here. It's great to be here from a not 10 o'clock time. So my southern hemisphere point of view is it's like 5 p.m. in the afternoon, approaching autumn as the leaves are falling, etc., etc. Welcome to everyone, and welcome to everyone who has come in from external, since we're doing a public talk also. So I've opened it up. If you have, it'll be largely like a demonstration, but I'll stop at various points and answer questions. I'd appreciate if they could be written, and because there may be much more people than can realistically do a discussion, I'll try to just pick a few of those and read them out. I may give some preference to like some external people or some really good internal ones, but if I don't get to your question, please, you know where I am and you can find me. So, without any further ado, let's slideshow this from the beginning. So this is a deep dive on Clang sanitizer testing with a particular focus around containers. It's normal actually to give like credits at the end, but you know, I found with other presentations, by the time you get to the end, sometimes you forget them. So credits originally, as I'm looking through the bugs on things that have been fixed so far, and the people who have been doing a lot of testing around these include these. This isn't a complete list, but there has been a lot of work, particularly on ASAN and UBSAN, and Elena and Marco are pretty much holding up the fort as far as a lot of the MSAN bugs go. The format of today is going to cover this in the order. So going to build up a few MSAN demos, a few UBSAN demos, and some conclusions in amongst those. I'll try to probably at least about every couple of these steps actually just stop and see what questions there are on that. So where was it next? For a start, the BuildBot containers are a way to actually reproduce things that actually occur in the CI environment. If we look here and remove the filter, we see all the BuildBot workers except for some of the install and upgrade tests are built on these containers. And if you download this with Quay.io, skip the repository, MariaDB Foundation BuildBot, and put on the append tag, you can get whichever build environment that we run in BuildBot. So one of the kind of hopes for actually doing this presentation is that if you come across a BuildBot problem, you now have the ability to actually run the tests locally and produce it and fix it, rather than pushing a lot of BuildBots and hope and fix on that. But that's the way. As it talks about MSAN, I'm predominantly going to be using this, wherever it is, latest MSAN builder with Clang 20 and Debian 12 on that. In the CI environment, it looks something like this from a test a couple of days ago. It's a about 4 to 5 minute compile, and a test run of roughly that time 14 minutes, and it does the big tests and all the other tests. I've intentionally tried to keep it very open as to what it actually covers. MSAN, I think a lot of people have come across it already. So it's a detector of uninitialized memories. It consists of compiler instrumentation and runtime. Importantly, note the reason I can actually do this in containers is that it doesn't depend on the kernel at all. There are the instrumentation of the libraries, and the user space is sufficient to do that. They say a typical slowdown is 3x. I think, Marco, you quoted slightly less than that with MariaDB so far. However, tests vary, mileage vary. It's popular, but it's there to find errors more than deliver performance. The reason that there is a slowdown is that MSAN uses a shadow memory, which is a mapping of every bit as a mirror of the user space, there to work out if something's initialized. When you have a compiler directive that says write a byte to this location, the compiler will instrument the code to also adjust the shadow memory to say this, 8 bits at this location has been initialized. And we'll look at some of the mappings there, though Marco's done a much better talk on it previously. So obvious ones, if you've got a branch condition around an initialized value, it's rather unpredictable. If you've got an initialized pointer to a memory address, you could get anything. It's not a segfault. The more interesting one, if an uninitialized value is passed or returned to a function call, it can be considered undefined behavior. It's partly too, you could argue that, in a function call, you can go, well, this first parameter defines whether this second parameter is good. But do you really want that to be in the code? Yep. And it also covers uninitialized data of the calls. Remember what I said about the shadow memory and the not shadow memory? Because of that, effectively every library needs to be instrumented to that MariaDB users or your code-based users, so that it knows when an uninitialized memory happens, because if it's not instrumented, the core memory will be updated, but not the shadow memory. The main document that I've actually spent more updating on this is on the wiki. And for these examples today, I'm going to be running the MSAN container. I'm going to be probably a little bit before. So this is the full container URL there. It's got instrumental libraries required for MSAN. It's got a CLang 20.1.5, Debian 12 I saw, and for the convenience of people using this for debugging, there is RR installed on the container. I haven't installed an editor, but I'm open to ways that this can sort of be improved without bloating it more than it already is, because it's a rather big container already. Because it's got MSAN on the title, doesn't actually mean the container is hard-coded to MSAN at all. It's a generic Debian builder. It's got the GCC versions of Debian 12, which are probably 14 point something from memory, although the C and C++ CXX for environment variables point to CLang. And yeah, okay. So waffled on a little bit too long on that, but let's get to it. So this is how you start a container. On that, I use Podman all the time because I like unprivileged services, and it's maybe just personal preference. But the breakdown is what here. Podman run or Docker run runs a container. RM means after you terminate the container, it goes away. TI is about standard input. I use this as a volume mount, so the source code exists on a directory, and that's passed into the container. And I've made it read-only because it's partly a belief, but yeah, that kind of thing. We've got a build directory of 10 gig. I just use tempfs, as this is going to be reused for the MTR tests. That's why it's a little bit bigger than what you might normally expect. worker and entry point. Pretty much because this is predominantly a BuildBot container, I needed to overwrite some things to get it back to a general use of a container. So, yeah, those are it. So let's get started on that. I'm going to start on, say, the 10.4 release on that. Because later in this exercise, I'm going to run into this container again. I'm just going to give it a name, MSAN 12.0 release, and again, a privileged, hope that's right. It'll tell me if it's right, because I want to actually do some RR tracing, which requires extra things. So careful with the privilege. It means that if you're doing anything under root, you can do things like escape this container by mounting things. How if you stay as a ordinary user within that, I think you're pretty right on that. So that environmentals. I mentioned before that CXX was set to CLang. Notably, there is no C flags set. There's an MSAN libdirt for convenience only, and there's a bunch of MSAN, UBSAN, ASAN options set by default. There's the symbolizer, which helps with your backtraces. The Galera library is not instrumented in any way. It's on a to-do project to actually work out how to do that properly. I did try, but I didn't quite get there. A build, basically MSAN on. I've disabled submodules. The linker flags, I pointed to the MSAN directory of the library and have used the R path to enforce that at the compile option. This was to work out a one definition rule, and the rest of these is because stuff wasn't instrumented and to make things quicker. But the full explanation is there on the code. So we compile that. It looks like what you normally expect to see in a build. Okay, I'm just going to check if there are any questions so far on that. And silence was the stern reply. Woohoo! All understood. Excellent.
Daniel,
okay.
You don't need to cap add if you do privileged as a flag. Just enough.
That's right. Yep. That's right. I tried to get a round with RR kind of needs a few things. It needs your cap p trace and your cap perf, I think, but it also needs a bunch of other things, and generally I couldn't actually work out how to incrementally add just enough capabilities or setcom filters to do that. But I may come up with an answer another time, or someone else might also, which would be quite welcome. Okay, that's there. CMake build dot and goes like that. But because, as we said, that takes a few minutes, here's one I prepared earlier on that. So, excuse me while I check my notes. Okay, so we looked at the environment variables. Okay. So what does it take to run a MariaDB server locally? I'm sure the same thing that is normally done in a container or outside a container. Install and MariaDB verbose. And so this is letting it run on a terminal. You may notice I have tmux installed, however, that doesn't actually mean I'm very proficient at it. So look at Podman PS. This is the container MSAN 12. Should we check that? Somewhere in here, the backup way to find it is the pointing fingers at the screen doesn't make much sense, does it? Is the container name is that one? So technically, I could do that. Okay, and if I do client MariaDB select one, strange enough, it works like that. I thought I'd give this opportunity to look at an example of what an uninstrumented thing looks like. The thing I haven't actually got configured in this library is this tinfo to use for the TTYs isn't actually instrumented in that. And the first thing we see is when we execute it, it comes up with an MemorySanitizer error on that. So as a quick thing to look at what is actually instrumented or not, if we look at our MariaDB library, we can see, the let it edit, the cursors, the tinfo, they are the standard locations, so they're not. The MSAN libs contains the instrumented bits of not only OpenSSL but C++. The other ones, the unwinds, the sibs, the compiler's actually taking care of those interfaces there, so the rest should be fine. And for comparison, SQL MariaDB is there. Also, that isn't too bright. PCRE is there. Well, heck, let's just look at the libraries are there. So those are the ones that are instrumented, which isn't a big list at the moment.
So Daniel, to a question, if a library is not instrumented,
yep.
If we were to call any function from that library, we would effectively get an MSAN error all the time, correct?
You will get a error if that function call actually changes any memory that is later read. So technically, you could get a library that just does a pure syscall and returns no value, and it would work. It's just if that library happens to change memory that we depend on it, or itself depends on, in fact, to get it done, which I guess is the large majority of the cases.
Right, so it's MemorySanitizer is keeping track of which memory is uninitialized. So if you are allocating some memory and then passing that buffer to a library that is supposed to fill it, then if that library is uninstrumented, then MemorySanitizer will think that it's still uninitialized memory, even though it's not.
Yeah, yep.
Return values, I guess, if it's just something that is returned in a register, that should work. I don't know about structured return values.
Yeah, it depends on, I guess, the ABI, and I don't know that off the top of my head. Yeah, so that's what that. If we want to do test cases, usual test cases, stuff runs. Eventually, I did mention it's a little bit slow, right? But yeah, goes through that. However, you've all seen that before, or most of you have anyway. So let's come to a case. Oh, actually, what I wanted to get through. Why not? Let's suite equals InnoDB. There is a small output discrepancy that you see in the result that's saying, trying to patch a result. That's actually a bug in patch that I submitted to get fixed. It's actually not outputting to that file that it's trying to patch, it's writing to a different file. So it doesn't actually need to print that error. So you can safely ignore those, and it took me a while to work that out. However, the next patch version, which just sounds like a double meaning, we'll have them fixed. If we look at one bug that is known to fail if I have left my environment clean, and this is one Yushin had up earlier. If we scroll up, ignore the MariaDB backtrace, go straight back to the MSAN one. Let's have a look at this one and see what it is. So if we split this, I normally go top down, but I guess results vary. So if we look at like SQL class.h, if I get my keys in the right position, plus 6295. What we see is that there is an address sanitizer reading one of these things as an uninitialized value on this line. It's an effective rows, an ID, or a message pointer, which could be null, so it's probably not that one. So it's not that. If we look to the next stack trace provided in down here, okay, uninitialized value was stored at that. So that SQL parse.cc 6521. Got the wrong one. Yeah, top one. So it's 3099. What we see, this is uninitialized value was stored at this location. That obviously means thread.affected_rows is uninitialized. And we see like 2 lines later it's called down to my OK with affected rows, which is the call on the top bit of stack. So thread.unaffected_rows is uninitialized. So let's go back to these stacks here and see where that's copied from. So uninitialized, go back to the next track. Okay, uninitialized value was stored at this. So let's look at that one. SQL class 3893. Okay, here we're copying affected rows to affected rows again. I think we're pretty sure that the row count that comes in the function is right. So it's still looking like it's effective rows. And I believe this is the thread class, but let's be sure. Class, yep, that's the thread class.
So is it adding an initialized value to an uninitialized counter, or?
It's effective rows plus equals, so it's adding itself.
Right, so it's if it was uninitialized before, it will be kind of garbage after this, I guess.
Yep. Yes. It'll be more garbage or something. So the final piece of the puzzle is look back further is to memory was marked as uninitialized here. So we see the top bit is allocating memory. It's not going to be in malloc. Yeah, let's have a look at the SQL list. Which list.h, and it's 675. We see that that's a boring mallet call, so it's not that one. So let's look up one further up the stack, SQL prepare .cc 6308. And here we allocated thread 0. We're doing a bunch of initialization. What the heck? New thread dot affected rows equals 0. Save that. Note on the editing on my right hand side that's actually outside the container, and because it's a mounted in, it just works the same way. So we build it again to incorporate that. Run the tests. And that's it. That's what it takes to fix that. And that occurred without any debugging at all. If we go a little bit further, it was in like the SQL layer, and Yushen's got a PR that you can probably approve based on this, right? But yeah, that's the thing. So anyway, the test work on that. So it's yeah, this was like I guess a fairly shallow one going through where we could actually just trace back a few layers in what was prevented by MSAN and get what was there.
So basically what the MSAN is able to do is you initially start with the shadow bits marked as uninitialized, and then any operation with a uninitialized shadow bit propagates and basically gives you the whole stack trace.
Yeah, so it sort of goes, well, it knows it's uninitialized, it knows it's copied, therefore there's more uninitialized,
yeah.
And it eventually gets there. So somewhere along the way, someone mentioned this was a rather controversial function, so let's have a look at it. So SQL build.cc. Let's just make it do nothing and see what actually impact that has. And mixing up the cursors. Okay. MySQL MTR, yeah, just see what it runs. It's a bit boring. I won't bore you with this because most of them actually passed. However, there is a small collection of ones that I know to fail. So let's look at those. On those. And I've probably done the noisy way of this. Oops, I didn't do force. Anyway, there are so like before, let's look at straight to what was generated as trace. I'm still at the bottom of the stack, so This first one is memory was marked uninitialized, and where is it marked uninitialized? It's inside ARIA. It's reading a couple of blocks and allocating while it's collecting the stats. The next thing is uninitialized stored, and since this is a mem copy, this is copying to somewhere else. And the final result is, after doing also in the stats collection, it's writing it out to a B-write file there. Yes, which is stored up there, which is copied again, and got the stack 4, and we see it's actually written out to a file here. So this is kind of probably an over masking of a thing. We've got a thing that a storage engine generated, and it's being written out to a file. There are, I guess, cases where undefined things can exist in areas of file, and the function was around var strings, so I assume, and the bit I deleted was like the last bit of the string was undefined. However, I guess when we got that kind of behavior, we've got to make sure that when we read that back in off the disk, that we know that a certain bit is undefined in that location as well. So I would dearly love to see a better place for this than, wherever these are actually called. It was just in table stats. But yeah, at least it's scoped that way. But anyway, that's an idea of how to work through the stack. That's right. What I wanted to actually do with this example was to let's show how we use RR on this. So we reset MySQL test mtr RR, the test name. And copy the thing right. We said before that like MSAN slows things down. Well, RR slows it down a little bit more, but you've got a recording at the end of it. Sorry, is there any other open questions on the channels while I'm looking at this and losing track of my windows?
The question is that, is this comparable to Valgrind's uninitialized tracking?
Similar. It looks like Marco's giving a full answer on that, but yeah, I wasn't going into this. Yeah. So yeah, I was talk titled around like Clang on it, so I was trying to keep it constrained to that. Okay, so as before, that test failed. If I want to do RR replay, MySQL test var log MariaDB MySQL d.rr/MariaDB0, and this is like it's the first instance there. Do the lazy approach, just continue, take me to the point where it asserted. So there was a bit about question about which environments this can run with. I guess this image is inherently a Linux image. If you're running on Mac, they run effectively a Linux VM to run this. Your mileage, if you are running on Windows subsystem for Linux, may vary. I don't know. I haven't actually tested it. However, RR does some very deep Linuxy things to implement itself. This is about what you expect at the die location. There is a bunch of sanitizer functions, and likewise later with UBSAN, there is a bunch of sanitizer functions that you can use in GDB to account for this. It's writing this buffer there. Look at that. Let's just quit for that. What I wanted to know was written earlier, and that was the address at which it failed. And so that was just before the stack trace. Said it had trouble with that offset 11 at that address. So let's, well, we can do that now that we're at the stack point. What is at that address? Let's test my memory on this. What are the 15 bytes? And what was the last item? Damn. Get my ChatGPT cheat sheet out. Units in hex and then bytes. X bytes at that location. So we see those ones, and that pretty much corresponds to this string here, carriage return, accounts, see all the 65 range up to that. As we were talking about the shadow memory on x86, this is a 5 something or other offset. So if we take 5 off the first number, we'll see the shadow memory associated with this. And for the first 14 bytes, there we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 are perfectly initialized, and then we get the uninitialized value there. If you want to debug this, what you can use is watch points, and you can say what's the location of let's see if I've got this right, Marco. So let's look at maybe not that first byte, but 21, 22.
You need to add a star before the pointer cast.
Before the pointer cast. I knew it was there somewhere. Was getting there. So is that right? At 20.012.
23, isn't it?
Yes, 3. Sorry.
You're watching the actual memory, not the shadow bytes.
Yeah, good point. So let's watch the shadow bytes on that. So let's do reverse continue. That's our breakpoint from before. So continue again. And this is the point where if we look at it backwards, the old value became initialized. So the point at which was initialized, and we'll find that this, was one of the allocations there. So I'm not going to fully resolve this one in this case, but it's just to give you an idea of you can watch the uninitialized and initialized and the shadow locations and the real locations to actually go forward and backs to see where it was. And Marco's done a presentation on that before.
Yeah, so the basic idea would be that now that you got to the point where the buffer was allocated, then you could put an additional watch point to some of the data that was initialized later. And then based on that, you could figure out why are these 3 last bytes not initialized? What should I change around that part of code?
Yep. So, that's general principles. And you get stuck on that. So the thing I want to actually point out now is that because this is in a container, we can, because the RR is pretty much a fixed version, that means, and all the environment's actually stable apart from the kernel, we can do things like tar up CJF, create a tarball of a MariaDB directory. Oh, except there's a bzip in the container. How about the compression? Can tell which bits I didn't test properly. So we can tar that up. A little bit big. And then we can use the same curl command that's on the FTP server to say, let's push that up. And that was remarkably quick. Not used to that. Yeah, and there's a save copy if you want another developer to help, and that can be done as an external party on that. Okay, so yeah, that was, I guess, a few demos. So let's, I guess, look at the status we're at now of everything. I fix MTOD. What I didn't mention is if inside the container there is a bunch of instructions there on the command line for everything. That's a slightly older one, and I made the mistake of putting spaces after slash, which makes it hard to copy and paste, but I'll get that fixed.
So, Daniel, there was when a developer was trying to run MSAN in the past, the biggest issue was actually getting all the environment variables the same as the ones in Buildbot. Can you go again over how you got the environment variables loaded when you started the container?
The environment variables actually set in the container. They're part of the container runtime. We've also actually worked on the server code base to actually make it a lot simpler too. Previously, you had to specify C++ libraries and your enterprise memory and probably a few other things. So I worked and put that under the with MSAN equals on option in the server, and that's how you can get a command line that is like so slimmed down to compared to what it was.
Okay, and interesting. So I'm not sure then how it happened then.
What's that?
I believe Dave was trying to reproduce this, and we had to tell him to make sure he sets the environment variables right. Somehow, probably in Docker, maybe that environment didn't load. Instead, since you're using Podman.
I think the thing that was likely missing is that R path. I'm trying to remember it from the other day, but I somehow didn't think that was matched, because the R path, I guess, on an executable means that LDD SQL / MariaDBD will actually load it directly from that. So I don't need to specify like an LD library path equals /MSAN. I don't need to do that because it's actually compiled into the executable. So okay. if we miss that one, you get into trouble. The trouble with like setting an LD library path is things like ls no longer works because LDD / bin / ls uses PCRE, and PCRE is one of the things I instrumented, but when it's instrumented in a thing that's not instrumented, it becomes a missing symbol. So that's pretty much the R path of an aspect has to be in there. Otherwise, you get a very growing long list of things that use PCRE libraries and OpenSSL style libraries and things that are in the core things that all of a sudden don't work. So you need to be careful to get that R path in there. I'm contemplating doing a PR that sort of says, well, making the MSAN libraries actually a option in the CMake, and that way that can be included there also.
Okay, so for anyone who's trying this, make sure that the environment is set properly and that the CMake line also sets RPath is probably the takeaway.
Yep. Yeah, Yushin actually sort of pointed me at the docs before I started editing today on them, and they got a little bit dated. Who would have thought developers leave documentation behind a little bit sometimes? Fixing that. When I actually get, I guess, Boost instrumented for like column store in there. If we look at like the BuildBot now, that it's got a few failures. However, if we look at like any one of those from recently, it's all just the one test, and it's archive big. So there's a waiting for a merge into the main, and that should clear it all up on that part. On that, plan to add a debug builder, and that's waiting on, and hopefully it can include Spider, because there's about 2 bug fixes. One I went through today that covers that. There is an improvement on making CMake debug more efficient. In the scope of the MSAN runs, remember about uninitialized values coming out of a function and then repassed to another function. There's a small bit of InnoDB does that, but a optimization level like of 2 just inlines that, and it's not seen by an MSAN anymore. So try to get that in the server and simplify that, but it's documented here on the knowledge base if you ever want to use that as a reference. Hopefully get to masking. Obviously, for any external people that have come along, there are a bunch of MSAN bugs still out there. This is 66 or so. What is also the case with here, there's a couple of these that are bugs to re-enable test cases that previously failed. Remember when I said that it hides, it needs to know about calls? There's something around fstat or one of the calls that sort of previous versions of MSAN didn't know about, but now they do.
Right, there was something, and actually 2 patches by Nikita Malyavin fixing it in more recent Clang versions. I didn't check which exact versions.
Yeah, but I think
I'm not sure if it was exactly fstat, but something similar, definitely. And InnoDB was one of the users.
Yeah, and there was a couple of cases around it, and I think the other ones you mentioned elsewhere to reduce those down. However, I guess Leonard's got you've got the Jenkins CI and that kind of thing. So I've got to, I guess, coordinate with people, and I guess giving this talk as the first part of that to see that everyone can be on a later CLang version, find some good bugs, and it's a matter of how old an MSAN or CLang do we actually really want to support. And I'm hoping if this is easy enough to use for everyone, not very not very old on that. Yep. Marcus documents, yep, link there on that. Okay, so was that all I had on MSAN? Yep, I think that was it. Okay, any other MSAN questions before I move on to ASAN and UBSAN? Rule, thank you for reminding me that no, that was ASAN, never mind. You found my patch. Well done on patch. Cool. Okay, I'll move on to UBSAN now. Okay, so UBSAN, I'm going to do ASAN, address sanitizer, and UBSAN all under like the same umbrella, even though they are notionally different. The important thing is you can actually run these both at the same time, which is kind of handy. Notably, you can't run MSAN and address sanitizer or UBSAN at the same time. They both play with memory models in different and incompatible ways on that. So that's why the same is. However, you can play with address SAN and UBSAN under the same thing, and as Rule found out with upstream, provided you don't have an unlimited stack size or something else, it can actually work quite well. Notably, in a container, we get the right one. You limit -a. There is a stack size already applied. There is a chance you might hit it. I am 8 meg. What do you think? Is that hittable or not? Not sure. I think in the code base there was some adjustments as to when threads were created as to how big the stack was under MSAN, at least. Unless. But yeah, keep that in mind, I guess, if you're running outside a container environment. Okay, that's all I had on that one. So on to address sanitizer. It's for detecting out-of-bounds aspects to heap stack globals. It's use after free. It's use after returning. And as Eugene, I think was a while ago, added an address use after scope into it, into that option. Undefined behavior is about, array limits, byte shifting, null pointers, signed overflows, and I've also got a bunch about, function pointers that don't map, and I'll get to example on that. The QA testing team at MariaDB PLC has a maintained list of exclusions here that I was going to get to that after I'd started it up. Anyway, let's start it up. So for this one, I'm looking back at our core reference. Where was the bit for starting the container? Just to know I'm not cheating on this. So here we start a container. I'm not using R this time, but I'll give it a UBSAN 10.6 there. For a start, I'm actually running on this on a slightly modified branch. So there was a bunch of UDF functions that have an open PR that hits in a lot of test cases. So it was just easier to not do this one. Anyway, so name UBSAN 10.6. 1 or 2 there. Go down to below MSAN. Okay. So for that, it's, as you know, slightly less than what I had on MSAN, and that's mainly just because of the instrumented libraries. Don't need to worry about those. There are things that I could exclude that would speed it up, but that's it. An important note is under UBSAN, I think it was, that the combination of unit tests and perf schema actually are incompatible. That there is a perf schema unit test that come. Perf schema unit test that fails. That's just an old MDev on that. However, based on recommendations, I'm disabling unit tests for that one. So start that one. While I mentioned this, the cases for the container with UBSAN and ASAN are much less, provided you can install a version of Clang from distro or otherwise. This can actually be run anywhere. There isn't anything exceptionally special about this container, except that it's got a very modern Clang version there. So you can run that on that.
Well, I would like to point out that using Clang's undefined behavior sanitizer is better than GCC's, because GCC doesn't catch some undefined behavior, like adding something to a null pointer.
Yeah, thank you on that. I could build. However, as we saw, it takes a while, so here's one I had prepared earlier. See, like these shortcuts. It's like as seen on TV aspects on that. Okay, so what do we want to do here? Right, so yeah, let's just run an MTR like we normally would. Whatever. With the UDFs kind of patched and fixed, there are not a lot of failures on this case. Can someone ping Yushin on the Slack to say it's actually still on if he wants to join? Evidently, I didn't close Slack enough on that. Okay. Before I sort of said the list of exceptions are kind of there. There's not that many left as far as like the existing bugs. Existing test cases in there, and as you can see, there's like a few float overflows, a few enum kind of overflows or usage, that kind of thing. But there's a lot of ones that have actually all been fixed that way. So as before, if I look to the documentations, you can fetch this filter. You can add it to the existing environment variables, and then after you're actually finding the newer bugs for that, or running your own rather than hitting across some of the known ones. But if you want to fix the original ones, obviously don't download the filter on that. What was my example for this one? Right. Yeah, so an example here is mtr main.plugin. And it's successful. What have I done? Yep. What happens when you do a test run through. So if I run that without it, what we get is a runtime error. And this is similar to what the UBSANs. We tried to call a function blah through a pointer that had a few extra arguments, mismatches on that. What it doesn't actually show in here is where the function it was calling was. So in this case, you have to look through the error log, as you've probably done before. And we see the example it hit was like at this line. Edit it. It's obviously a very short version of a function. And since I've already shown you the answer, let's dash pop. And as we can see, yeah, we needed to change buff to avoid, add the two other things, even though we don't use them, and because we needed a printf that needed to be back to a character to print to the output. And so that was the simple fix for that one. Others around bit shifting, float overflows, I think they're overall a little bit more complicated than what is on some of the MSAN ones to fix, but I could be wrong. Mileage vary a bit on that. Okay, so if we look at like some of the conclusions, I didn't get to the conclusion of the MSAN, so I'll do that now. That overall they're reasonably accurate, especially compared to compile warnings. The shadow memory calculation keeps track of things really well. It's true to what it says. So if it finds an error, typically it is definitely an error that undefined behavior is being moved around in some way. And yeah, so as a general things that identify the problem is pretty easy. If it's hard to fix, it's because some of the code is complex, as Sanya will tell you over a beer, I'm sure, on that. Generally don't fight MSAN. It's usually right, and if you overmask stuff, it's just going to hide errors that show up later. And yeah, and that it's that way. So where to from MSAN now? There's an example of an MDev in MSAN, was this one that Ramesh kind of found in testing. And it was effectively a parse error on a table statement was left over, and the alter sequence table used a parsing result out of that. So while I've actually kind of fixed the error itself, which was adding a bunch of initialization again, that there is an opportunity to use MSAN more and use like Undefined on things like the parser state at the end of queries. So when you get to the next one, that it will actually treat any access on the newly parsed statement as incorrect if it never was initialized. Sorry, jumping back to UBSANs, SAN. On the continuous integration, we've got some existing ones. There is a bunch of things to update. I'm currently being blocked by a few things that are quite hard to or would be extensive to mask out. But the Buildbot config is actually ready to go on that. If you feel like fixing bugs, there are quite a lot of them still open. Most of them being reported, I guess, by Roel and Alana and have good test cases with them. So if any community contributions around fixing those would be very much appreciated. Okay. On UBSAN and that, in the JIRA, they're mainly UBSAN errors. We've got a lot of old code base, so we've got a lot of things that were previously tolerated by older compilers or GCC compilers, which is why we're pushing a little bit more into, especially on the CLang on the testing side. And there's only a few blockers and things to filter out that will actually have a very green CI on UBSAN and ASAN together. So while you think of last questions, I just want to actually thank the sponsors of the MariaDB Foundation. Won't list them out, but there are a lot of them that kind of pay our salaries and make sure that we can do things in the community and with the engineering team to get MariaDB better for everyone. So that's all I had. So any final questions?
Well, not a question, but thanks for this effort. It's very great to see also ASAN as on the path towards being a mandatory builder.
Yeah, it's good. Welcome. A few things to go. Yep.
Very good presentation, Daniel. I think it made it quite clear what MSAN does and how developers can make use of it. It was a tutorial that we were lacking for sure.
Yeah, welcome. Thanks everyone for coming along. Much appreciated. And if you think of questions later, I will be back tomorrow because hey, it's 6 o'clock and I'm going out to dinner. But happy to help out. I have a couple other fixes in progress for some MSAN, ASAN things. I just need to write a bit of bug reports on them. Write a better commit messages and understand them a bit more before I submit them. So that will be coming. And silence was the standard replies. So I'll leave you to it. And for those watching the recording later, thank you for watching it till the end, or at least skipping to the end.
Thank you, David.
Okay, should I quit now? Because it seems like the chat's still going. Good. Yep, thanks, Phil. Okay, farewell, everyone. Have a good night. Happy coding.